Hello everyone, welcome back to ptet.chemistry channel. So this is Mr. On, and I know many of you are having your AS level or A-level examination coming up, and I thought that this would be a good opportunity for me to actually show you this set of infographics that Cambridge International actually released on their Learner Plus website, which usually would cost us extra money, but they have made it available free of charge ever since the pandemic lockdown had happened globally. Okay, so these are very interesting infographic sheet because it shows you how they link the A-level topics together, irrespective of whatever examination board they are doing. Even if it's not Cambridge International, you will be able to see how different kind of things, like in this case the orbitals, can relate to stuff like these relative atomic or formula masses. Alright, so I will not necessarily go through every single thing, but I'll highlight a couple of things as I go along, and you will have realized that I will have already completed compiling my playlist for A-level topics, where within each topic I will have gone through different variety of questions that could be asked in an exam, not necessarily just for the Cambridge International A-level, but whatever A-level you're doing, there can only be so many different variations of how they can ask the concept. Yeah, so you can use those as you please. Yeah, just share them widely with your friends, your network of contacts, so they can benefit more people. Okay, so without further ado, I'll get started on these what we call topic connections. All right, so all these files are available in a Google Drive folder, and you can use them as such. Just make sure you credit Cambridge International, which is, it's them who produced this material, not me. Yeah, okay. So the first bit is about, so there are 10 of them altogether. The first bit is about particles. So the particulate nature of matter, as you know, involves the proton, neutron, and electrons. And as you know from your periodic table, so this is a new representation of periodic table actually. I mean, personally, I really like doing the nuclear number on top and proton number at the bottom. I am pretty old school. I'm not sure if it's just a new way of representing it, as I've seen it in the new periodic table. I still like that because, when we talk about carbon-12, this is what we talk about, carbon-12. It becomes important when we usually use it for our definition of relative atomic masses or formula masses or isotopic masses, etc., etc. Yeah. So all these things involve the relative masses and relative charges, which are typically asked as part of atomic structure. Okay, so these are all subatomic particles, where within the nucleus you have the protons and the neutrons, which have no charge, and you have a negative charge electrons circulating around the nucleus in that region of space we call orbitals. Yeah, so in definition of nuclear number and proton number enables you to derive or complete how an atom or an ion would look like. All right. So you have this set of relative masses, which are supposed to know how to define. They haven't really stated it there, but there's also something called relative isotopic mass, which is to do with exact mass, and that is very often one of those definitions that they really like to ask you, together with any of these. They are already all stated in the AS level specification. All right, so the idea is we take it all relative to this standard, which is carbon-12. Yeah, so it's 1/12 the mass of an atom of carbon-12. That's your standard. All right, so the concept of mole, there's the Avogadro constant. It refers to the number of molecules or atoms of ions in 1 mole of that substance, all right? Which could be solid, liquids, or gas, which could be atoms, molecules, or ions, all right? So you got to know how to relate them together, whether you have oxygen molecule or whether you have oxygen atoms. They are slightly different, and you should be aware of those things, yeah? Talk about the nucleus of an atom. So this is actually a different topic already. Talk about the shape of the orbitals. We talk about how, when you talk about nuclear charge, that is the that is due to the proton and nucleus. We talk about shielding, which you should be able to explain very fully. We talk about something which is the net effect, which is called effective nuclear charge. So the nuclear charge is just Z. The effective nuclear charge is Z effective. I will not use abbreviation before actually stating out the whole thing, because no one understands your abbreviation unless you state out the whole thing and abbreviate it. Then you can use the abbreviation the next time, all right, in your explanation or whatever. Obviously, these trends, the changes in this trend can affect ionization energy, all right, and people are always confused. Students are always confused between ionization energy and melting point. They are two different processes. You should be very clear what is ionization energy and what is melting point, all right. Then I talk about mass spectrometry, which you cover more in A2 chemistry actually, but we in AS we talk about a simple mass spec of a molecule, which can give you the atoms. So there will be the atoms. As you know, bromine has two isotopes, 79 bromine and 81 bromine. It's roughly 1:1. Actually, in reality, it's about 59 and 41. I've heard 49 and 51, if I'm not mistaken. But it's roughly 1:1. That's why you get almost equal height. Then what is this thing here? That is going to be 79 bromine. 79 bromine. You're going to have 79 bromine, 81 bromine. And then you're going to have 81 bromine, 79 bromine. And you will have 81 bromine, 81 bromine. Each of these has a charge. Each of these is charged, because if they are not charged, then what are on your axis? Your axis are actually abundance or relative abundance or percentage abundance, and you have mass over charge. Sometimes they put a m over z. If your species is not charged, you will not see it. That's why it curves away. I think some of the UK A-level have started to learn something called time of flight. It's quite a new thing in A-level chemistry in the UK A-levels. Fortunately for most of you who are doing the in Cambridge International, you don't really do time of flight, but they do curve away, okay, as a result of it being deflected towards the charged plate, because it becomes charged species. Yeah, so you only see 3 lines rather than 4 lines, because these two mass, 79 plus 81, is the same as 81 plus 79, and you get 2 of these overlapping. That's why you get almost double the intensity of 1:1 there. 79 plus 79 is the lower one, 81 plus 81 is the higher one, and these are combinations of the middle bit. You will have done all this really. So the next bit is on these mole calculations. A lot of people get confused with mole calculations, because it could easily be a experimental planning or design question, because it could be easily a whole practical chemistry kind of question, or it could be a really lengthy theory level questions where they guide you one by one. I've a series of videos on these mole calculations where I like to use fractions in my mole calculations. I like to do my bookkeeping properly, so you can watch out some of those for how I do it and see whether you like that kind of method to do your bookkeeping properly. Yeah? But what is more important is that there's a series of videos on these backward titrations that usually involve dilution or starting from solid and finding out their percentage purity or percentage composition of the impurity, etc., etc. They all can be quite simple if you draw some diagram. Okay, so go through some of my problems. You can watch the video how I do it, rewind it, and then pause it, and then try to do it yourself. Okay, so I got all my questions from Jim Clark book on calculations in AS and A-level chemistry. So it's a really good book, and I find it really helpful. So that's it really on this the first of 10 short videos. I guess on this kind of thematic infographics, okay, where this one is talking about the particulate nature of matter. That's to do with these things. All right, okay, so I'll see you in the next video. Don't forget to subscribe if you find my channel useful, and share with your colleagues, your students, or your friends through group chats and whatsoever, so that they can benefit more people. All right, thank you for watching. Check out my other topical playlist. Yeah.